In algebra, we often look for the single point where two lines meet. This represents a unique solution. However, linear systems can behave differently depending on the relationship between the equations. Today, we explore the fascinating case of infinite solutions. When two equations represent the exact same line, every point on that line is a solution. Because a line consists of an endless series of points, we say the system has infinitely many solutions. They are perfectly synchronized. A system with infinite solutions is called a consistent dependent system. It is consistent because solutions exist, and dependent because one equation is simply a multiple of the other, providing no new information about the variables. Look at these two equations. If you multiply the first by 2, you get the second. Algebraically, they are identical. If you try to solve this using substitution or elimination, you will encounter a very specific result. When variables cancel out completely and leave you with a true statement like 0 equals 0, it confirms the lines are identical. This is the mathematical fingerprint of a system with infinite solutions. Unlike a single point, the solution set here is an entire line. Any pair of coordinates that satisfies the first equation will automatically satisfy the second, because they are effectively the same mathematical rule. In slope-intercept form, infinite solutions occur when both the slope and the y-intercept are identical. If the slopes were the same but the intercepts differed, the lines would be parallel and have no solutions at all. Let's work through an example using elimination. We multiply the first equation by -2 to prepare for adding them together. Watch how the terms align perfectly for cancellation. Adding these equations results in 0 on both sides. Since 0 always equals 0, our algebraic test confirms that these two lines are coincident. Every point on the line x minus 3y equals 4 is a solution. Now let's try substitution. We will plug the expression for y from the first equation into the second equation. This is another common way to identify the nature of a linear system. After distributing the -2, the 6x terms subtract to 0. We are left with -2 equals -2. Again, the variables have vanished, leaving a true identity, proving infinite solutions exist. A quick shortcut is to check the ratios of the coefficients. If the ratio of the x coefficients, y coefficients, and constants are all equal, you are looking at the same line expressed in two different ways. To recap, intersecting lines have one solution. Parallel lines have no solutions because they never touch. Coincident lines have infinite solutions because they are actually the same line. Remember these three signs of infinite solutions. Visually, the lines overlap. Algebraically, you get a true statement like 5 equals 5, and structurally, one equation is just a scaled version of the other. Test your knowledge. Take a look at these two equations. Can you determine if they represent the same line? Think about the slopes and intercepts or try the ratio test we discussed. If you rearrange the second equation, you found it simplifies exactly to y equals for x plus 2. Since both equations are identical, this system indeed has infinitely many solutions. Mastering linear systems allows you to predict how equations will interact. Whether there is one solution, no solution, or infinite solutions, the relationship is always hidden within the coefficients. Thank you for learning with us. Generated by Vision Solve AI.